Hello everyone, this is my lab report. So this is an introduction. This lab is about a motion with constant velocity. The purpose of this lab is to observe the motion of some object that is moving at the same speed without changing direction. For example, a rolling pin. Then, when would the object move with constant velocity? So from the physical idea, the object will move with constant velocity if the net force is zero. The net force is just the sum of all forces acting on the system. For example, in this graph, the F1 and the F2 negate each other, making the net force to be just equal to zero. And when the net force is zero, the system is in equilibrium. From the velocity update formula, if net force is zero, the final velocity is just the initial velocity, making that the velocity is constant all the way. And from the position update formula after it, we found out that the final position is just linearly related to the time because the VI here is just a constant. Based on the physical idea, we conducted our experiment. The system is a pen, the surroundings is just anything else. We used the velocity update formula and the position update formula to model the motion because this formula works well in predicting motion iteratively. And finally, my result is that the object moves with constant velocity when the net force is zero. And there's a positive linear correlation between the position of the object and time. So here's the procedure of our experiment. We first conduct the experiment, then build the model, then track the video, and then we have our discussion. And this is the experiment of a rolling pin. Then after the experiment, we build a model. The initial position and velocity are determined by the pen's actual initial position and velocity recorded in the video. And here's the code. The net force is a zero vector because we hypothesize that the pen will only move in constant velocity if the net force is zero. And here's the code. Then, using the while loop, velocity update formula, and position update formula, we predict the motion iteratively, and this is our code. So you can see that the velocity formula is here, position update formula is here, and the while loop is here. And this is the result from our model. Then, we set up our tracker. As you can see, the positive x-axis is just the same as the route of the pen. And we also set up a calibrator using the meter stick, so as you can see from the blue line here. And this is the result from our tracker. As you can see, it is like a straight line. Then we have our discussion. Comparing the actual position versus time graph and the model, we found out that they both seem like a straight line, which indicates that there is a linear correlation between the position of the pen and the time. However, as we graph them together, these two lines actually diverge, and the actual position of the pen falls behind the predicted position. This might be because of the friction that we ignored in our model. The friction leads to energy dissipation, and it makes the net force no longer equals to zero. So it gives a small drag to the pen and makes it fall behind. What's more, in our lab, several sources of error includes firstly, the time interval I said, which is 0.033 seconds, might be too large to make the actual measurement accurate. And what's more, during our recording process, our camera moves to the left a little bit, making the position measured to be at the left of the position of the pen if the camera didn't move throughout the video. Finally, my conclusion is, even though the friction force from the table might exert actual force to the object, since the friction force is sufficiently small and our result generally matches the model, we conclude the object moves with constant velocity when the net force subjected to it is zero, and there's a positive linear correlation between the position of the object and time. And here is some extension. If I flip the axis, then the direction of the velocity was flipped. The object moves in negative direction. The position versus time graph will be like this graph. As you could see, it is moving to the negative. What's more, I also thought about if we need the net force to be zero to make the velocity constant, then the forces that give zero net force might be firstly the normal force from the table, which is here, and secondly the weight of the ball, of the pen. Just to note that here, although there is friction, but friction makes the net force to be not equals to zero, so in conceptual model we measure the friction to be negligible, but the friction will actually exist in the actual experiment. And thank you for watching. That's all.